Hi, my name is George and I'm an engineer here at Monolithic Power Systems. In this video, we'll introduce our full programmable mEZ power module. Using an innovative virtual bench programming tool, this module uses software to configure various designs with different output current and voltage requirements without any hardware changes. Simply enter your design parameters into the programming tool and you can simulate and evaluate your design instantly. Need to make changes? Just re-enter different parameters and re-evaluate. Programmability allows you to configure, test, and change key performance attributes like startup, ripple, and transients. Prototyping is now much simpler and faster. Let's get started. First, we'll show you how to configure the mEZ power module using our field programmable evaluation kit, which includes an I2C communication interface device, an evaluation board, and mEZ power module. Additional equipment required includes a power supply, a DC load, and a laptop with our virtual bench software to configure the power module and run simulations. To begin, connect the board to the I2C communication interface device. Plug your mEZ module into the board and connect the board to the power supply. Be sure to connect the board to the power supply using the correct voltage requirements. The voltage range for this module is 4.5 volts to 36 volts. Turn on the power supply to start up the module. We will connect with 12 volts. Finally, connect the I2C communication interface device to your computer and start up the virtual bench software. Once the power module is recognized by the software, click Direct Programming Mode to enter your desired values. In the Basic Configuration tab, select your desired output voltage. For example, enter 5 volts. You can also modify the switching frequency. We'll use 1000 kilohertz. After programming your module, go to the Write Memory option. Select RAM mode for the module and click Write. This will automatically write the settings to the mEZ power module. To demonstrate the virtual bench setup, we'll supply a 5-volt FPGA with a 12-volt power supply. After powering up the supply, you can see the output voltage is around 12 volts. Using a meter, you can see the amount of voltage delivered to the FPGA from your customized mEZ power module. After watching how easy it is to program your module using our evaluation kit, we'll run a simulation showing you the results from the test bench setup versus our virtual bench software. To set up your bench, you'll need to configure the input voltage and desired output current with a DC load. Using our virtual bench software, you can duplicate and simulate those same parameters without the use of a test bench just by clicking on the simulation and programming option. You can select the virtual power supply to the desired input voltage. For this test, we'll use 12 volts again. Click OK. Click the DC load on the left to enter the output current. Enter 5-volt output voltage and 3 amp current. Click OK. Finally, select your desired frequency. We will select 1000 kilohertz. Click Next. Now that everything has been set up, we can run the simulation and measure the results inside the virtual bench. You'll need an oscilloscope to compare the two. Let's take a look at the startup waveforms. The virtual bench results are on the left and our test bench results using an oscilloscope are on the right. You can see the rise times and voltage transients are practically identical. In our next test, we'll simulate a load transient with a change in input from 3 amps to 1.5 amps. As the simulation shows, the results are the same. For our final simulation, we will measure the output ripple by selecting the state ripple in the results window. You can see the virtual bench results on the left and test bench results on the right. As you have seen, our easy-to-use virtual bench allows you to design and simulate your customized module within a few clicks. Once your design is finalized, you can quickly place your order at monolithicpower.com and receive your customized part in days. For more information, please visit monolithicpower.com.